On July 1st, 2025, telescopes in Hawaii detected something moving through space. Too fast. From the wrong direction. Made of the wrong materials. Scientists gave it a name, 3I Atlas, and a classification, Interstellar Comet. But the more we study this visitor from beyond our solar system, the less sense it makes. Right now, 3I Atlas is doing something spectacular. It's making its closest approach to the Sun. October 29th marks the peak, perihelion, astronomers call it. The object passes within 210 million kilometers of our star. That's 1.4 astronomical units, just inside the orbit of Mars. This is when things get wild. The heat is blasting material off its surface. Gas, dust, metal, all erupting into space in real time. It's the most active this ancient visitor will ever be during its entire journey through our solar system. And we can't see any of it. The Sun is directly in our way. Call it bad luck or cosmic irony. But our view of the most important moment is completely blocked. We won't see 3I Atlas again until December. But here's what makes this object so unsettling. How it got here in the first place. You probably know about the first one, Oumuamua. That cigar-shaped object that flew through in 2017 and sparked all kinds of theories. It was weird, but weird in a completely different way. Then came Borisov, the second interstellar visitor, and honestly, it was almost boring. Just a normal comet doing normal comet things. Weirdly, not weird. Now we have a 3I Atlas, and it's breaking three major rules. 1. Size. Oumuamua was maybe 400 meters across. Borisov stretched to 1 kilometer. But the 3I Atlas could be 5.6 kilometers wide. It's massive. 2. Speed. Atlas moves twice as fast as both of its interstellar siblings. 3. Direction. And this is where things get strange. Oumuamua came from above, from the north. So did Borisov, at a diagonal angle. Both basically hit us head-on as our solar system moved through the galaxy. We kind of ran into them. 3I Atlas T-boned us. It came from the side, from the direction of the galactic core. And it's aligned almost perfectly with the plane where all our planets orbit, only 3 degrees off. Pluto is tilted 17 degrees, and we think that's unusual. Space is 3-dimensional. This object could have come from anywhere. So what are the odds it hit us perfectly side-on? Astronomers traced it backward. Over 10 million years of journey through space. They identified 93 different stars that 3I Atlas would have passed during that time. The closest it came to any of them? 0.3 light-years. That's 63,000 astronomical units. Right now, it's 1.4 AU from our Sun. We are the closest thing this object has encountered in over 10 million years of travel, maybe much longer. Because 3I Atlas didn't come from the crowded spiral arms of the galaxy where we live. It came from the thick disk, this ancient, quiet region above and below the galactic core. A place where things don't get disturbed, where collisions are rare and objects just drift for billions of years. Which means the 3I Atlas could be 7.6 billion years old. Nearly twice the age of Earth. But age isn't the strangest thing about it. The really weird part started showing up the moment we pointed our best telescopes at it. Before the 3I Atlas was officially discovered in July, it had already been photographed. A satellite called TESS caught it back in May while searching for planets in other star systems. For 1 month, TESS accidentally tracked this interstellar visitor as it moved through the orbit of Jupiter. And that's when the first anomaly appeared. Astronomers expected the 3I Atlas to get brighter as it approached the Sun. They predicted the brightness would increase by a factor of 1.25. It increased by a factor of 5. Something was reflecting way more light than it should. That's how we knew this wasn't an asteroid. It was forming a coma, that fuzzy cloud of gas and dust that surrounds a comet. But there were two problems. First, the light bouncing off 3I Atlas was polarized in the wrong direction. Most objects in space have positive polarization. 3I Atlas has the most extreme negative polarization ever measured. The light was bouncing back instead of scattering to the side. Second problem, location. 3I Atlas was over 5 astronomical units from the Sun when this coma formed, way out beyond Jupiter. It's freezing out there. Normal comets don't wake up until they're much closer, around 3 or 4 AU. Their water ice needs serious heat to melt. So why was 3I Atlas already active? Because it's not what we expected. When we pointed our most powerful telescopes at 3I Atlas, we found that the coma wasn't water vapor. It was carbon dioxide, CO2. The ratio was 8 parts CO2 to 1 part water. That's basically the inverse of normal comets. Everything was backwards. Think about dry ice. That smoky fog you see at concerts. That's frozen CO2. It has to be stored at incredibly cold temperatures. But the moment you take it out of the freezer, it instantly starts turning into gas. It doesn't need much heat. That's what 3I Atlas was doing way out there beyond Jupiter. Its surface was covered in dry ice that started sublimating the moment it got even a tiny bit of warmth from the sun. But then something shifted. By late September, as the object crossed inside the orbit of Mars, water vapor suddenly appeared. Massive amounts. Like a fire hose running at full blast. More water than we'd expect from a normal comet at that distance. And then there was the metal. Over the summer, astronomers detected nickel in the coma, but no iron. Which is strange because nickel and iron come from the same place. The core of dying stars. They're almost always found together in space objects. So where was the iron? We don't know. Maybe some process separated them billions of years ago. Maybe the CO2 was dragging nickel atoms along with it, but wasn't strong enough to pull iron. And then, just like the water, iron suddenly appeared in late September. The ratio shifted. Nickel and iron together, like normal. 3I Atlas was becoming more normal over time, but it was getting there in the weirdest possible way. And it wasn't done surprising us. When 3I Atlas first started forming a tail back in the summer, it was pointing the wrong way. Comet tails are supposed to flow away from the sun. That's how solar wind works. It blows outward, pushing gas and dust behind the comet like a streamer. 3I Atlas had a sun-facing tail. The tail was pointing toward the heat source instead of away from it. Most likely, this happened because the coma formed so early. The object was still too far out. The solar wind wasn't strong enough yet to push the cloud backward, so all that gas and dust just accumulated on the warm side, the sun-facing side, before the wind could grab it. By September, a normal tail had formed, short and fan-shaped, pointing the right direction. But by then, we had a chance to see it up close. On October 3rd, 3I Atlas passed within 0.19 AU of Mars, closer than it would come to any other planet in the solar system. And we have cameras there. The Perseverance rover pointed its lens at the night sky and took a 30-second exposure. Then another, then stacked them together. What you get is more of a streak than a clear object. Not great, but it's something. The European Space Agency's ExoMars orbiter got a better shot. You can see the bright coma, but still no detail of the actual surface beneath all that gas and dust. NASA's Mars Reconnaissance Orbiter has the most powerful telescope in the Mars system. It could have captured the details we need, but that image hasn't been released. Maybe it was never taken. because by the time 3I Atlas made its flyby, something else was happening back on Earth.